There is an interesting property between for all x p of x, I mean existential quantifier and universal quantifier. I'll take an example and explain you. So what I mean to say is, let us say we have a propositional function p of x. Let's say this p of x, the propositional function p of x is greater than 3. Okay, and let's say the domain of disclosure is 4, 5, 6. Okay, and now what happens to the result for all x p of x? So for all x p of x will be true if for every element in the domain, if this proposition is true, then it will be true. Now just try to substitute this each one here. 4 is greater than 3, true. 5 is greater than 3, true. 6 is greater than 3, true. Therefore, for all the values, since it is true, p of x is true, for all x, p of x can be written as true. Got it? And now, what happens for there exists x, p of x? Now try to understand one thing. There exists x, p of x will be true if there is at least one value in the domain for which this p of x is true. Now, since we already know that for every value in the domain the proposition is true, you need not actually check it, which means if for the same domain and for the same propositional function, if for all x p of x is true, then definitely there exists x p of x will definitely be true, right? You need not check it at all. It is an interesting property. Please make a note of it. There might be a question on this. So what is it? Whenever for the same domain and for the same propositional this function, whenever for all x p of x is true, there exists x p of x will be true. Is it true in the reverse way? Which means if this one is true, can you say that this is true? May or may not be. Let's take an example. In this case, this one is true and also this one is true. But then there might be some cases in which this one will be true but this one will not be true, which means there exists some elements for which p of x will be true, but it doesn't mean that for all the elements p of x will be true, which means even though there exists x p of x is true, it might not imply that for all x p of x is true. So just to take a small example, we can take the same one. Let us say propositional function is x is greater than 3, and let us say the domain is 2, 3, 4. Now what happens to there exists x p of x? Now there exists x p of x will be true if p of x is true for at least one value in the domain. Now if you take 2 and substitute here, 2 is greater than 3, false. 3 is greater than 3, false. 4 is greater than 3, true. Which means since for at least one value propositional function is true, we can say that there exists x p of x is going to be true, isn't it? Yes, this is true. Now since this one is true, can you say that for all x p of x is true? Now let's see here for this example what happens for all x p of x. Now if this one has to be true, for every value present in the domain, the propositional function has to give a true value. Now if you substitute 2, it is giving us false. Therefore it is not true, it is false. What can you say? Whenever for all x p of x is true, we can say that for there exists at least x p of x will always be true, but the reverse need not be right. Which means if there exists p of x is true, it doesn't necessarily mean that for all x p of x is true. Also other relation is whenever for all x p of x is false, there exists p of x may be true or false. So check this. For all x p of x here is false, and so there exists x p of x may be true or false. It may or may not be right. For example, if you take the domain as 2 and 3, that's it. Then this one will be false as well as this one will be false. Got it? So what did you understand from this? Whenever for all x p of x is true, definitely there exists x p of x is true, provided that p of x is same and the domain is same, right? But in case if for all x p of x is false, this may or may not be true. Similarly, if there exists x p of x is false, definitely this one is going to be false. Check that. If there exists x, p of x is false, then definitely this one is going to be false. Why? You just see this one. In this case, in this propositional function and in this domain, there exists x, p of x is definitely false, isn't it? This is definitely false. Now what can you say about this? For all x will definitely be false. If there is no x for which p of x is true, then how can you say that for all x p of x will be true? Got it? So you have to use your intuition there. Don't by heart those results. You need not by heart them. They are just trivial, but when you are answering them in the exam, just use your intuition once. Okay? And other thing is something called as precedence. So the precedence of for all and there exists, these two will be highest compared to any other logical connectives. So just to give you an example, think about this one. If I have for all x, p of x or q of x, now which x is bound to for all quantifier here? So which x is having this for all? So does it really mean like this, which means this for all is applied to all this, or does it mean like this? So what I mean to say is, let me write it clearly. See, simple. I'm saying that there exists and for all has highest precedence compared to any other logical connective. So whenever I write for all x, p of x or q of x, what does it mean? Does it mean for all x, p of x or q of x, or does it mean for all x, p of x or q of x? What does it really mean? So which one is right in this? So that is where the precedence is going to be useful. I told you that for all and there exists have highest precedence compared to any other operator. Therefore, whenever there is for all present, it has to be executed first and then the other connectives. That is why it is done. Got it? Okay. So what are the other things we can say is there is something called as bounded variable and free variable. Bounded variable and free variable, right? So it is not a very important concept. Whenever you see any variable being applied this quantifier, then we can say that this variable is bounded by this one, right? Now if you see here, it is not actually bounded to any quantifier. Therefore this one is free and this one is bounded. And then there is something called as scope. These are theoretical definitions. There will be no questions on this, but since it is given in the textbook, we are talking about it. Now what is the scope is, now if you see for all x, the area or the length of the question, I cannot say question, the length of the composite proposition over which this particular quantifier is valid. In this case, the scope of for all x is only this part, right? So anyway, don't dig deep into it. Leave these definitions here. They will not be asked. So bounded, free and scope, just know about them, that they are these words are there in this question, in this subject, so that if you see these words, you will not feel that some question is asked out of syllabus. But then don't by heart it. No question might be asked. That is what I feel. So don't dig into it. Leave it there. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. And whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.